Welcome back, day 4 of electromagnetic motion. We have our convertible car. It's a transmission and direct drive car, right? And we're gonna test its speed. We're gonna see how fast it goes. So usually our cars, your mom's car, your dad's car, goes miles per hour, and that's how we tell how fast it goes. With this car, we're going to do meters per second, and we're going to calculate the velocity. We're going to calculate velocity by calculating distance per time, and we're going to do this by measuring out 3 meters. So your ruler, we usually use the inches side. Today we're going to use the centimeter side, and you need 300 centimeters to make 3 meters, right? So you'll set down your ruler, or you can use a tape measure and measure out 300 centimeters all the way down here. So here's the start line. Right here is the finish line. And we're going to compare. We're going to compare what's faster and what drives better, what drives straighter, right? Whether it's the transmission side, which is with the bottle right here, or the direct drive side. Cool. All right, here goes the transmission side. Start line and go. It's going very straight, but not too fast. Okay, let's restart. That was 9 seconds. And again, you can use your timer to time this, or you can look back at the video that you record if you have that capability, and we'll use that to calculate. Alright, here goes direct drive. Alright, 1, 2, 3. Not too straight, but it looks like it's going a little faster. So that was 7 seconds to get from the start line to the finish line. Okay. So with science, you want multiple points of data. So let's do it one more time. Here's direct drive. That was 5 seconds. That was faster. Alright, let's do transmission. That was 7 seconds, nice. Okay. So with that, we could do it as many times as you want to average it out. But we'll stop there, we're pretty content with that. Alright, so that was a flat surface. Now we're going to attempt this on an incline. And you know, you can go around the school, find a ramp or any hill that goes uphill. And you want your start line to be at the bottom of the hill, and your finish line to be 3 meters away from your start line, on top of the hill, or close to the top. So we're going to start off with the transmission drive, and let's see how fast this goes up. Any predictions? Oh, that's pretty good. Slow and steady. So that was 10 seconds. Let's try it one more time. Alright, 10 seconds steady. Now we're going to try the direct drive. So put any predictions that you think are going to happen with this. Ooh, it's a little crooked and it's struggling, but it made it. That was 14 seconds. Let's do it one more time. It's struggling a lot. And 17 seconds. So now we see the difference between a transmission drive and a direct drive. Right, one's got a purpose that works better on a flat surface, and then one's got a better purpose for inclines. All right, now go do the math on to figure out the meters per second on your vehicles. All right, so now that we got all of our data, we're gonna do the funnest part of this project, which is the math part. And we're gonna calculate velocity by dividing distance by time. We have two different data points, right? So we have two different sets. We have the flat, and then we have the ramp. And then we have our direct drive, and then we have our transmission, right? So for the 3-meter flat race, we did 7 seconds, right? So I'm gonna have my assistants divide 3 by 7. And you put that whole number on the board, or you could just do the first two numbers. So it'd be 0.43. You're gonna round it up, okay? And that's yeah, so that's 0.43 meters per second. So now let's calculate the transmission. It took 9 seconds for it to reach the finish line of 3 meters. And let's do 3 divided by 9. All right, so we're gonna put that number here. So 0.33 meters per second. Okay, awesome. So now we got that. Let's do the ramp. So direct drive took 14 seconds to go up a 3-meter ramp. So let's calculate that. Okay, so that's 0.21 meters per second. Okay, now let's do the transmission. So it took 10 seconds for it to go up a 3-meter incline. Cool. So that's a 0.3 meters per second. Awesome. Okay, so now that we're looking at our data, so we have our 4 numbers here. So the bigger the number, the faster it is. Okay, so we can see that the direct drive went 0.43 meters per second on a flat surface, but it only went 0.21 meters per second on an incline. Comparing that to the transmission that went 0.33 on a flat surface, and then it went 0.3 on a ramp. Right? Do any of these numbers surprise you? Is it what you expected? Right? A lot of folks would think that this would go fast on an incline too, because it went so much more faster on a flat surface. All right, now comparing them the other way around is direct drive and transmission on a flat surface, right? So the flat surface numbers for direct drive were a lot higher, and for the transmission it was 0.33, right, which is a little bit lower. That's a whole 1 point lower. And the opposite is true for the ramp, right? In the ramp, the direct drive went 0.1% or 0.1 point lower than the 0.3 of transmission. Okay, so what do these numbers mean, right? So we have 0.43 meters per second. That means that walk 0.43 meters per second, right? So 0.43 meters, 0.3 meters, 0.3 meters. If I'm only going 0 meters, it'd be a little bit slower. 0.2, 0.2, 0.2, 0.2. Walk, I don't know. Yeah, like 1 meter per second would be like huge steps. Right? So that's a lot faster than 0.3. Alright, so now we've learned how to use math to calculate the velocity of our little cars, and now we know that math is a very valuable tool for science.